Okay, last time on Dragon Ball Z, what we did was we learned about the sum of cubes, the difference of cubes, all those cute little like things that I told you you would be given anyways, which you really don't have to worry about memorizing. Yeah, we're gonna factor this. So what is the cubic root of x to the third? Oh, fantastic. What is the cubic root of 27? Fantastic. Okay, so now we're gonna follow that whole mess. You remember like Tuesday when we were like a plus b, and then there was like this a squared plus ab nonsense, something like this. Yeah. And then we use the acronym SOAP to help us, which same, opposite, always positive, right? Okay, so with that being said, yeah, go ahead. Just use this one. With that being said, a is going to be a squared, which is x squared, minus 3x, and then plus 9. But because I'm using this identity, yeah. We took x because that's what a was when we took the cubic root. Yeah, it's little girl in the front row. On the next one, we're going to do the same thing. What is the cubic root of 8x cubed? 2x, right? Because there's that x chilling, right? Okay, what is the cubic root of -1? Close.
0.
-1. Okay, it does matter. It does matter. Okay, so now we're going to have same sign, which is of the original. Then we're going to have a squared. So 2 squared is 4. X squared is x squared. And then we're going to have opposite sign. That's going to be a plus this time. And we're going to take 1 times 2x, which is going to give us 2x. And then -1 squared, which is going to give us +1. Questions, comments, concerns? Okay. Remember, if there's a multiple choice question, don't do all this junk. All you're going to do is type the original and then type your answer choices and see if those graphs match up. Polynomial identities, basic, and squares. So go ahead and title your notes. Polynomial identities, basic, and squares. Okay, so mathematicians discover patterns in math all the time. When they find something that always works, it becomes part of our collective math knowledge. Some of these facts are called polynomial identities. And we have seen a few already, like difference of squares. In order for mathematicians to know the identities they discovered are true, they must prove them. To prove, first check the accuracy of the identity by plugging in any number to see if it works. If it does, perform the operation to see if it gives you the other side of the equation. Okay, so really quick, Karen thinks that she has discovered a new polynomial identity. So I want you to go ahead and write down what she has discovered as the polynomial identity, and we need to prove or disprove her thinking. Okay, Blessing's already saying it's going to be disproved. Okay, now what we're going to do here is we want to take this side and we want to see if it's equal to this side. So what do you think we're going to do?
Provide variables, well, not variables, provide numbers to go.
Okay, you could plug in numbers. Okay, you can do it that way. Or what we like to do also is we could multiply this guy out, right? Okay, so we could multiply this out or we could plug in numbers. So we're going to do it both ways. All right, so give me a number for A. I heard 4. And then number for B?
18.
I got 2. Okay, so on the left-hand side, I'm going to plug these numbers in. So that's going to give me 4 plus 2 squared. And then over here, we're going to have 4 squared plus 2 squared. We're trying to see if these things work. So what's 4 plus 2?
4. 6.
Oh my gosh. 6 squared is going to give me 36. On this side, what's 4 squared? And then what's 2 squared? Golly. 16 plus 4 is going to give me 20. Are these equivalent numbers? No. Karen is wrong. Poor Karen. Justine does not like trust things just because she is told them. She wants to see if there is a difference of squares identity that is actually true. Help her prove or disprove this. Okay, so go ahead and take a second. Write down Justine's proof. So Justine had this. Okay, and so give me something for A. Okay, well, give me something for B. Fantastic. Okay, so we're gonna do 6 minus 7 squared equals 6 plus 7, 6 minus 7. Okay, well, what's 6 minus 7? Well, negative 1 squared is? Fantastic. Over here, 6 plus 7 is 13. And then 6 minus 7 is? Okay, and 13 times negative 1 is that the same thing? No, Justine is, all right. So Prisha cannot remember if the perfect square trinomial identity is that or that. Help her prove or disprove the identities to know which one it is. Okay, so I don't know, I just work here. Okay, so give me, oh, yo. Okay, so on the first one, give me an A and a B. Okay, and B.
8.
I always do a bigger number on the second one.
21.
No, we got one. Okay, so on this first one, I'm gonna plug in. So 4 minus 1 squared equals 4 squared minus 2 times 4 times 1 minus 1 squared. Okay, so we're gonna simplify this junk and see if it works. 4 minus 1 is gonna give me what? And 3 squared is? Fantastic. 4 squared is, and then negative 2 times 4 times 1 is negative 8. And then 1 squared is 1, and then minus 1. Over here on this side, we got 16 minus 8, which is what? Minus 1. Okay, so does 9 equal 7? No, this guy's not right. Okay. Over here. 8, 9. Yeah, makes sense. Okay, over here, we're gonna plug in those same exact numbers and see if it works. So we got 4 minus 1 squared equals 4 squared minus 2 times 4 times 1 plus 1 squared. When I simplify this, it still gives me 9 on this side. Over here, this is 16 minus 8 plus 1. It's gonna be yes. Okay, now, remember our little SOAP acronym?
Yeah.
Okay, think about it. Same, opposite. Oh, well, no. Uh-oh is right. Same. Oh, same as the other thing. Opposite. This should be opposite. And then always positive. So looking at this, we can go ahead and say that it's going to be this one's wrong because it's positive, right? Yes, ma'am. Okay, so what did y'all say a second ago about this negative right here? Would you tell me that one of those numbers could have been negative? Yeah. Like A could have been negative and made that sign negative. Yeah. Not normally supposed to happen, but it can.
What if B in this scenario, if B was negative, like it had -1, that would work, right?
Yeah.
Yeah.
Because then that would be plus here.
Right.
And then that would be minus. Yep. All right. So let's go ahead and take a look at the next one. Man, y'all talking a lot today. Okay. The polynomial identity. Yo. I would. All right. So the polynomial identity x squared plus y squared squared equals x squared minus y squared squared plus 2xy squared. This is the, are y'all done? Okay. So this is the Pythagorean triples. This is what you learned back technically in geometry, like algebra 1, like what you took last year before you met me. Okay, you technically learned this. It's just been a minute since you've seen it. Okay, so go ahead and take a second, plug in any values for x and y to generate the Pythagorean triples. So for instance, we have 1 here, 2 here, and we're going to use the Pythagorean theorem in order to solve for c. So for instance, we have c squared equals 1 squared plus 2 squared. 1 squared is going to give me what? And then 2 squared is going to give me, all right, and if I took the square root of that, that would give me square root of 5, right? Okay, so we got 1, 2, square root of 5. All right, so on the next one, I want you to try 2, 3. Okay, so let's talk. Ready? Okay, so the only one that we get like a whole number for is this 3, 4, 5. Okay, so your Pythagorean triples are actually going to be 3, 4, 5. Okay. Okay, other examples of Pythagorean triples are going to be 5, 12, 13, 6, 8, 10, 9, 12, 15, and 3, 4, 5. Okay, I would make sure that I write these down. You should know these roughly. Actually prove this polynomial identity. So we're going to use the Pythagorean triples in order to make this work. Okay, so go ahead and write that down if you haven't already yet. 15. Oh, that's square root of 61. Okay. All right, so what we're going to do is we're going to take 3, 4, 5, and we're going to put them in here to see if they work. So 3 and 4, we're going to plug in. So we're going to say 3 squared plus 4 squared equals 3 squared minus 4 squared plus 2 times 3 times 4 squared. Awesome. So many numbers. So what's 3 squared? What's 4 squared? If I add 9 and 16 together, what am I get? Okay. And that's squared, right? Yep. All right. Over here, I have 3 squared, which is 9 minus 16. What's 9 minus 16? Over here, I'm going to have 2 times 3 times 4. That's going to give me 24, and we're going to square it. So 25 squared, what is that?
1,000 something.
625. Negative 7 squared is going to give us positive 49. And then we've got 576 over here. 576 plus 49 is going to give us 625. So it does work. All right, so I want you to take a moment and I want you to do 1 and 2. Tell me if this works or if it doesn't work. So true or false, does this actually work? And then tell me why you think so or why you agree. Okay, so on the first one, are you ready? Ready? On the first one, what number am I plugging in?
4.
Okay, 4 to the 4th power minus 16 equals 4 minus 2 to the 4th power. Over here, 4 to the 4th power is, you said 256 minus 16. That's going to give me 240. Over here, 4 minus 2 is going to give me 2. 2 to the 4th power is going to give me 16. Those don't equal, so false. Okay. All right, on the next one, give me an A. What number? Okay, give me B. Wow, thanks, friend. Okay, so 3 to the 3rd power plus 8 to the 3rd power equals 8 plus 3 times 3 squared, which is 9, minus a times b, which is 24, plus 64. Okay, so y'all gotta help me out. Ready? 3 cubed. Man, I'm yelling over kids that are not paying attention.
I'm paying attention. Me too.
Okay, 27 is 3 cubed. 8 cubed is gonna give me what?
512.
512. 8 plus 3 is going to give me 11. And 9 minus 24 is going to give me 15. Plus 64 is going to give me, and that should be negative 15, right? Somebody check me.
Oh, no.
So we got 9 minus 24, which is going to give us negative 15, plus 64 is going to give us 49.
49.
So over here, this is going to give us 449 times 11, which is 539, which is true. What numbers did you use, Macy?
I used
2 and 3? Might have plugged in wrong. Might want to check that one. Okay, so on the next one, I got true. Did you get anything else? No. Okay. Why you say that?
Never mind.
Okay. All right. On the next one, I got false because it doesn't work with 1. Okay. And then on the last one, what numbers did you use?
7.
Okay. All right. And if I plug all that in, all right, so this will give me 1 over here, 49 plus 42 plus 36. When I add all that up, I get 127. Over here on the left, if I do 7 times 7 times 7, that's going to give me 343. And then 6 times 6 times 6, that's going to give me 216. If I subtract those two, that's going to give me 127 equals 127. So that's true. Okay, so coming back to this one, ready? Oh my gosh, can we pay attention? Okay, cool. So notice how I plugged in 0 and it works. But if I plugged in 4, or if I plugged in 10, it does not work. Okay, so you have to kind of check with multiple numbers. Don't just assume one number works. Okay. All right, good talk.
Multiple.
I would try at least 2 numbers. I would try an odd number and an even number. And I would probably not choose 0. I would
So odd number and even number, then even number.
an even or an odd or something like that. If it doesn't work for one of the evens, it's probably not gonna work for any of them. Okay. Shh. Okay. Last one. Yes, you did. Last one. Oh, on this one, to agree or disagree? Agree? Okay, so if I take 7 and plug it in for X, she's gonna get 14 on both sides of the equation. So let's check. Okay, so 7 cubed is going to give me 343. And then minus 7 is going to give me 336. Over here, 7 plus 1 is going to give me 8. So 7 times 8. And 7 minus 1 is going to give me 6. So 7 times 8 times 6 is going to give me 336. So how did she get 14 on both sides of the equation? Because she done messed up. Okay, good. All right, so disagree with the fact that she got 14 on both sides, but it does work. Okay,